All right, good morning, everybody. It is 9:10. I'm going to get started. Welcome to this second day of class. I have seen that some of you have enrolled after Monday. For those of you who are new, welcome again. This will be our second day. What we did on the first day was to get to know what the course is about, walk through the syllabus, and what I would like to do today is take a look at what data science is. And as I explained on Monday, we will spend today and what is going to happen on Friday discussing this topic. But today will be the day we'll start diving into what data science is. What I didn't get to do last time was to have a breakout session at the end, and that was because I wanted to have to complete introducing the course and the syllabus. And today I will make sure that we have that 10 minutes towards the end to introduce one another. Welcome again. What I usually do when we start a class like this, and this has been something I have done in last semester also, is to get us started. So I will begin, the session begins at 9:10, but I will be online 10 minutes earlier. And so you get to say hi, and if there are some questions that you have that are not necessarily related to the class, you can start asking them. But when we start talking about things, I want to have a starter, a question, something that could keep you busy, or respond to. And so we'll start by having two questions today. And as we go on, we will have more and more interactions. So just as a reminder, you'll mute yourself, and everybody's muted yourself. Feel absolutely free to turn on your cameras, especially when we have discussions. If you have a question, you can put it in the chat, or you can stop me and ask me a question. That would be perfectly fine. But I start by a warm-up question. And so the first warm-up question I have for you today is this. In your opinion, when do you think the field computer science got born? So I'm going to write the question in the chat session, and so you will write an answer. So there are fields like physics or biology or mathematics that really are old, and so they could go back to BC. But computer science is a relatively young field. So the first question I have, and this will be an important one to look at when we start discussing this, is when do you think computer science as a field got born? So you start. You may want to think about it for half a minute or so, but not necessarily too much deeply. And then I've given you a clue that this is more a young field. But let me see what you have to say. That will be my first question, and so take your time and try to respond. And as we do this, more and more people will join us, hopefully. And so that will be my first question. I'm going to give you some time to think about it and type your answers. Just simple numbers will be sufficient. As you do this, I'm going to also be thinking about the second question. I know some of you are, thinking about this and answering, and you should participate. The second question I have is going to be this. We have now in a session where we are taking lectures remotely, and this is the result of COVID, and it has been quite some months now. And so there are so many things have changed, and it has upended life, and there are so many new things that have happened as a result of it. I was to think about what might have come as a positive side effect. And so I don't think there is anything positive that has come out of this one, but there might be some things that have had, just like we have had side effects for medicines we take, there might have been some positive side effects to having things on a remote session. So think for a while what you may consider is a positive thing that has come out of things being done online. I have my own things that I have seen are a positive thing in terms of delivery of lectures and how it has changed how I would have done things. But think for a while. It could be, you sleep better. It could be get time to do some other thing that you haven't had time before, whatever it is. But I did not want to minimize what it means in terms of the things that it has really affected us. But I want to say question number 2 is, what positive side effect has come as a result of having remote learning? That's for you. And I want people to think about this and start responding. All right, this is something that you will continue doing, and when we get to break, I will get to see more of you. And for now, I have things set up, and we are going to get started with today's topic. Before I get to speaking about what data science is, and I will engage you, I want to make a couple of notes. The first thing is, on Monday, I said some very nice things about Oswald, and I have asked you, and many of you have already signed up there to be using as a learning platform. This was what I have been using. The people who run the system decided, because of some issue that they have had, not to necessarily maintain it at a regular pace. So I've decided to switch to Blackboard. So if you haven't heard from me via Oswald, that was the reason. And some of you might have had some difficulty getting access yesterday evening. And so we will be going back to Blackboard. This will be not a surprise to very many of you because you have been using it. It's not going to change much of it. As a result of that, I have updated the syllabus, and I have updated the things that needs to be in terms of where things are submitted and stuff like that. So all of you are already on Blackboard, and so it should not affect you. Announcements will come through there. So for those who have followed along, there are a couple of things that I have posted there that you will see. So we will be using Blackboard and not Oswald anymore. That is point number 1. The other point is, as I mentioned, we had some numbers, and I spent some time telling you about your backgrounds in terms of which disciplines are represented for those who are taking this as 475 and for those taking it as 575. Since Monday, there has been some more enrollments. And so a few of you have enrolled since then. And I know 2 students have enrolled from Tri-Cities campus, for example. And so we've got the latest number. This is the latest number we have. And so I want to update, and I want to those who have enrolled later, welcome to the course. I browsed a little bit and looked at how you said when I asked it last lecture where you're coming from. If you're curious, something like 80% of the class is taking these numbers combined from the Pullman area. Another 10% is on the west side of Washington, and another 10% will be from all different places. And so this is how the composition looks like. And every time I see something interesting out of the interactions we will have through chat, I will come back and tell you them, either through the announcement or when we get a chance to get in class. As you all know, on Monday, I told you about the pre-course survey, or an initial survey, where I ask you about your backgrounds, and this has been out. I was extremely happy on Monday that many of you took it right away, and so more than half the class, so we've got 82 people now enrolled in the class, more than half of you have already completed it. I take this one, and as you have noticed, there are a number of questions that ask about your background, so it is important that you complete it. So for those who haven't completed, and I had given you a week, in part because some of the questions ask about what the syllabus is, what the topics are, what courses you have taken, and some of them may require you to go back and look at certain things, and therefore I didn't want to rush it, and so I said, I'll give you the rest of the week, but let me bring it now closer so that we have a better planning for what is going to happen next week. So for those who have not completed, I would like you to complete it by this Friday. So make sure that you take care of it today if you can. I have been watching, and I will get back to some of you in terms of the things that are of interest, but a quick note, at least you will hear back from me. And so please go ahead and complete the survey. This link is, the slides will be posted on Blackboard. For those who have seen, I have also posted last lectures slides on Blackboard. The recording will be made available on Blackboard. So you can get this link when the slides are posted after the session today. But I would also just separately send it in an announcement. And so completing it will help me understand you. I will help me know your background. And to some degree, it will also shape how the course will unfold, what courses we will emphasize on, and what courses we will spend less time on. One of the things that will happen is next week, there will be, other than the normal times when we meet, Monday, Wednesday, Friday this time, Helen, the TA, and I will get her to introduce herself in a second, will be leading a tutorial on R, and I would like us to know what will be a good time for doing it. And so completing it will tell us the level of interest, but it will also tell us, because I would know the classes that you have, at least select times that would work. It will be extremely difficult to make everybody time requirement made, but I think we'll make it at a time that will be good for most, if not all. And it will be available, the slides and the recordings will be available, and so if you miss it, you still have a chance. So for that reason also, having to complete the survey will help us get started with planning early. Let me use this chance for Helen to unmute herself and say hello. So she was not there on Monday, but let me do that right away before we get continuing. Helen, can you introduce yourself?
Yep. Hi, everybody. I'm Helen. I've been TAing data science for a couple of years now, mostly. I am one of Asifa's students, and I'm sorry I couldn't make it on Monday. I had jury duty, so I did have a good excuse, but it's good to meet everybody. We can talk a little later in the breakout rooms.
Right, wonderful. Thanks, Helen. Okay, I'm going to continue now, but before I start today's discussion, does anybody have any questions so far? You hear me clearly? Okay, great. And feel free to turn on your camera so that we can see each other. And if you have questions, you can interrupt me, as I said, or you can use the chat room. I will be watching, and Helen will be monitoring the chat room as well. All right, before I get started today, there were a couple questions that came on Monday's discussion, and I have answered them towards the end, but let me bring them up again. One of them had to do with class project. We spent some time talking about it. I told you about the importance of it. But the question I had, one was who gets to form teams. We will come fourth week of this semester where I will talk about projects and have ideas and things like that. At that time, it will be a time to actually form teams, and so you will get to know each other better. But if you have already friends, or if you have an idea for a project and you have somebody you want to team up with, it's okay. So you will get a chance to team on your own, or I will help out. And a team means a team of two. In some cases, when the project is larger, a team of 3 is allowed. So team formation could be initiated by you, or I could help out. The other question I got was, for projects, can undergrads work with grad students? And the answer is yes. And I gave you an example where a successful pairing had happened in the past, and I encourage that. Naturally, sometimes it becomes more on the grad side and the undergrad side because of the difference in backgrounds. But if that becomes an interest, and if you have an angle to tackle it, that will be welcome. And we can discuss that when the time comes. There was another question that I didn't get a whole lot of time. Yes, last time when I was describing about what the prerequisite, the kind of background you need, I mentioned linear algebra, and there was a question on the chat session that asked us what topics do we have to review, and this will become clearer as we go. And so I don't have a list, but I think you will get an idea for where your deficiencies are as we go along. And so there will be material that will be available, and so every time you see a place where you need more to spend, you will do that. So there isn't a pre-specified list of topics I want to give you now, but every time, whenever there is a need for mathematical concept or an algorithmic concept that needs to be reviewed, I'll try to do it in class. If not, I will point you to a place where you would go and have to refresh your memory on. So the short answer is not much to worry about. And I have not seen anybody describing themselves through the initial survey that I have seen so far where I would be concerned that they don't have enough background. You will know it when you see it, and do spend the time needed once we get started if you see a deficiency. All right, this is a topic that we will be spending today's discussion on, and this will be a topic that we will follow up on Friday. In the beginning, there was a question about somebody who was asking for an assignment, and if you've seen the table that I laid out on Monday, we will have 5 assignments throughout the semester, and they will be more focused during the few weeks of the semester in the beginning, but then the later portion of the course will be heavy on project and the midterm exam that you have. And so the first assignment will come out this week, and it will be a result of the discussion we will have now and the result that we will have on Friday. And so you will get to a week to complete it, and somebody was very eager to know what assignment one was. It's not out, it will be out on Friday, and you will get a week to work on it. What we will do is look at this question: what is data science? And I've got an outline, what the kind of things that we would want to be talking under this. And so the first 2 is what I think we'll be able to finish today, and the other 2 will be what we will be doing hopefully next week. And I might get started with this landscape of perspectives. And whenever here there is a need for a participation, I'm going to invite you, and because I have you here, I can see when hands are raised and when you want to discuss. And so be ready to participate. And generally speaking, I will take some time when I have a slide that's got material to it so that you can take your notes. I would advise you to have something to write with so that you can take your own notes than what you would see here. All right, this is the outline, and I'm going to get started with this. Let me call it hype. And by that, I mean things that have been said in the media, things that have been around for a while. And this sort of things started maybe close to, 6, 7, 8 years ago or something like that. That would be the place where I would say more and more of the term data science being used, the term and the attention to it being drawn. And so sometimes, and this is a place where I want to start by having to be cautious about, is there might be things that were around already and that were existing, but they have come to get newer attention. And because of that, there might be some anxiety. And so I want to acknowledge that first. This is a quote I have taken, or these are points I have taken from a data science course that was taught by a statistician and a mathematician who put together a course at Columbia University around 2013. And so they wrote a book, and that the book is actually goes by that name, Doing Data Science. And there is 1 or 2 places where I would either quote or make a reference to it. And so this is a place where this people who have spent quite some time in industry and try to teach a large group of people around this idea of data science. And this is the place where they have in their introductory section talk about this hype that I'm telling you about. And so one of the things is about a lack of basic terminology definition. And so you get a clue now for what I mean by that. And we had spent some minute or 2 in last lecture giving a 1-line definition of what data science is. And so there is, generally speaking, compared to other things that we know are more standardized, things that we know are in the discipline, things that we know have terminologies that are well defined, here we have some lack. And I want you to be the kind of people who would try to sharpen those sort of things. And I'm going to come back to this point again. So that's one thing that would be eyebrows raising. The other is, there is also something that you would feel people who would say, we've been doing the kind of thing like this for a very long time. We just didn't call ourselves data scientists. We didn't call the field data science, but this is something we have been dealing with and working on for a long time. And they might feel their work and their input has not been recognized. And that's another good thing to consider. The last point is it could get a little too much, and sometimes it's good to be not to do too much of that, and the hype can be crazy, and I want to reduce that. But if you go past the hype and start to look around, in fact, there is something new. It is not something that has been existing all the time. It is not something that people have been practicing all without any distinction. There is newness to it. And what is the ring of truth? What is the thing that is new about it? It is the fact that there is access to a larger body of knowledge. And this is something I know having talked to some of you by email and having seen your responses to the survey, that you acknowledge this. There is access to a larger body of knowledge and methodology, as well as the process itself. And this body of knowledge and methodology and the process has got two fields in it that are central. And these are statistics and computer science. When we talk next Friday, my point will be more anchored around papers that I will post and good articles, and those articles would make this point even clearer. And so there is a methodology, there is an access to knowledge, and there is a process that has foundations in both statistics and computer science. And this is a quote from what the book I mentioned earlier. So my hope is that as we go through this course and you build the skills that you would need and understand it better, you would contribute to this pursuit of sharper definition. And your input in terms of topics that are of interest to you will impact, to some degree, what we will cover in this class. Now, last spring, I taught a course, and then I'm going to spend time talking about this slide. And it is a busy slide, and it has got some material. But some of you remember we took the automata and formal language class. That is a computer science class. And then, so you might not have seen the book. I used a new book on theory of computation, but there is an older book. And one of the people who wrote that book is John Hopcroft. And so John Hopcroft is a computer scientist at Cornell, and he and two other people are writing a book called on Foundations of Data Science. This is a theory book. This is a theory book that tries to look at what the foundations of data science are. It has got a very different perspective. It has got a very different goal than what our course is. Our course is applied. Our course is on more of doing data science and the things that you would need. But this book tries to talk about the foundations, the theory for it. And so I have captured 2 or 3 paragraphs from the book, from the introduction. And I have made a link to this book available on the syllabus. And the link to the book, which they have, with their writing it, is available also on what you see at the top. And so let's spend some time thinking about this. And now you will see my question for the computer science when I asked you when it was born. These are our ages, and particularly John Hopcroft is somebody who has made some fundamental contributions to graph algorithms. Some of you might have seen his name if you've taken graph algorithms on matching, for example. He has is one of those people who had made those contributions and wrote many textbooks at the time. And so here is how that discussion begins. This is their introduction. And so computer science as a discipline began in the 1960s. Now you can go back to your answers, and some of you, I remember somebody saying 1930s was computer science was born. They could make a case in some ways, but that is, as a discipline, was way too early. And so this is a time when it was born as an academic discipline. And the emphasis was on programming language, on compilers, on operating systems, on the mathematical theory that supported these areas. These were the kind of things that were called computer science. And now you can also see the vast majority of this class, so especially taking it as an undergrad one, are computer science students. So you would immediately see the courses you have taken, or you are taking right now this semester on programming language and compilers and operating systems and the mathematical theory that supported these areas. This is what the foundation for the course was. And courses in theoretical computer science covered automata theory, that's the theory of computation, regular expressions, context-free language, and computability. All of these terms should be familiar for those who have taken 317, for example. And this is the 60s, and in the 70s, algorithms became a topic. This is the place where you would say, what would you do when problems are hard to solve? How do you come up with approximation algorithms? How do you deal with intractability? And what will be heuristics? Is there a way for us to give guarantees on solution? Those were the 70s where algorithmic theory came in. And the emphasis all along was to make computers useful. And so the device was there, was one of the greatest inventions of our times. And so to make that one useful, we needed this thing to support it around. And this was the theory we had. Today, and by today now you can insert 2000s, and you can insert, in fact, yourself, and this is the time when we are in now. There is a fundamental change taking place, and the focus now is more on applications, not on making the computers useful, not designing compilers for them and having operating systems, but on applications. There are very many reasons for this. And I think probably one of the most important reasons is the merger of computing and communications. Most of you are young, and so you would probably don't know what it looks like when people were making a phone calls with a phone that got, you have to ring things around. That was what communication was. If you needed to communicate, you would have a device for its own, and it will have nothing to do with computation. And if you need to compute, you will have these machines that are very big and something that will stand, if you are lucky, and the time when they become personal computers that would sit on a desk. But computing and communication were things that were separate. Now we have changed it fundamentally. And so you know what your cell phones do these days. And that has changed it. That has changed it, and that has generated the need for applications to a very large extent. And so that is one point, one very big point. Computing and communication has changed it. They have merged. And then as a result of this, we have now enhanced ability to observe, collect, store, and these are very important terms now. And you will see these things unfold in the course of this course, for lack of a better word, in the course of this course. Observe, collect, and store data in the natural sciences. I know we've got physicists in this class, we've got biologists in this class. So the natural sciences were already all the time data rich, but the way to have them now where data is available has increased in a very big way. So this has the natural sciences, commerce, no need for a lot of explanations on that part, and very many other fields. This calls for a change in our understanding of data and how to handle it in the modern setting. Communication and computing merging, the ability to observe, collect, and store data, both in the natural sciences and in fields that are driven by business. This has changed our understanding of data. There is another big thing that has happened. Very big thing that has happened. You take it for granted because you're born in it, but we've got the web, we've got internet. And that has become another place where we have a lot of opportunity. All of these businesses that you see around now are born there. Social networks have come as a result of this. You all are on Facebook, most of you are on LinkedIn. And so you have this idea of how networks would grow. And some of you have taken the network science class and that I teach in the spring, and some of you may take it next time. These things, the web itself and social networks, have given us much larger structures and data sets, and it has given us opportunities and challenges for theory. The people who wrote this book are writing a Foundations of Data Science book. It's a theory book. And so what we are looking at here now is to have a understanding of these places and what things are playing a role to find out what theory is needed. So I have spent some time telling you about this one and unpack them, and then so the slide will be there. And the book is a good one, although its objective is different and it is linked there. But what they are up to is to find out now if the 1960s was where computer science was born, and the emphasis was on making computers useful. And I told you the kind of things that this would be needed for. From the 1960s to today is what I wrote up there. It's to 2000s, it's like 40 years. And so the theory that was needed for those 40 years was what was listed there: automata theory, algorithms theory, and regular expressions and things like that. If we were now to pay attention to the change that has come because of applications, and we were trying to say, what foundations are we going to need for the next 40 years, just like the last 40 years have benefited by having an understanding like this, what would they be? That is what the question they try to answer in this book. And so they try to find out what the foundations of data science would be, and to try to develop what is needed. Here is a place where the person who asked me the question on what do I need to revise from my linear algebra. You say linear algebra, what topics do we need to review? I think this slide is a good place to see what topics are needed. Most of you do not need my motivation to tell you what courses to take and the kind of justification for why your program is set up the way it is. But sometimes it's nice to see them in context. And so this paragraph also shows you that type of connections. So traditional computer science remains highly important, and they are going to be, researchers of the future, including yourself in computer science, will benefit by having this to able to understand and extract useful information from massive data arising in applications, but not just to make computers useful for well-defined problems. Well-defined problems like sorting, well-defined problems like search and things like that. For the newer applications, you would need a different set of skills, a different set of theory, and that theory is what at least this book tries to identify. And so the major change that has happened now is increased emphasis on probability, statistics, and numerical methods. You all have had probability and statistics, but we have more and more need for that type of knowledge in traditional computer science and numerical methods, and that's where the linear algebra part would come in. So I wanted to spend this time pointing out this one and basically telling you why this one is in the syllabus as one of my references. I'm not going to come back to this book. For those of you who are inclined a little bit more mathematically, even though the course is not designed in that fashion and we're not going to go to too much detail, that book will be, you will enjoy at least some of the chapters in that book as a new one. But takeaway from here is there is more emphasis on numerical methods and probability and statistics compared to what traditional computer science would have made us do. All right. Thank you for your patience with that slide, and you will come back and look at it later on for your own. But I want to talk about now what the thing that has enabled the data revolution is. This is the place where I would want discussions. This is the place why the slide is empty. So if this was in a class, I would have made you raise your hands and say something. So we're going to spend a little bit of time, to giving you a chance to do that. So what enabled? So we talked a little bit more theoretically in a way. What sort of things have happened now, and by now I mean the last 5-10 years, that we would say has made big data revolution, things that have made data science a field, things that have enabled this. So I'm going to start now. Feel free to put something on the chat, but raise your hands or say something. And then if I see there, chip storage. So Gordon is saying chip storage, completely agreed. I think this is probably faster so that I don't have to make people speak. Growth of social media, great point. Easy data collection. When you will be surprised by how great you're doing when I display my answers when the screen shows up later. Huge availability of data, increased computational ability. I like that answer very much, and we're going to mention that as a big bullet point. We have become powerful in computing. It's amazing what these cell phones could do in terms of power, but we have also become very sophisticated in algorithms, and so I'm sure that person who said computational ability means more on hardware, on computing power, but algorithms are there. Storage is coming again and again. It's very, very true, and I will talk about that. I think I like this. I like this than people wanting to talk. I know some of you prefer explaining, so you're very much welcome. This will be a nice place, but I like what I'm seeing now. Decision making based on data, that's true. Sensors, I like that answer very much. We have lots of them. Some of them are intentionally mounted wherever we want them. Some of them are there without our knowledge, and they keep collecting, sensing, that is. Algorithms. So I'm going to have this recorded, and so you'd get a chance to see your own answers. But I think that at the pace that it is going, some of you may miss some of those points. But every single one of them that's coming, I did not notice anything that I would disagree with. There might be different ways in which we want to say them, but let me keep you a chance to participate if you haven't seen anything that doesn't represent what you okay? Our ability to use, so that there is data, there is storage, there is availability of it, and then we have ways to work with it, and so you can phrase them in different ways. Data mining is there. Communication speed, an excellent point that was not raised before. Devices generating more data, that is an excellent point. We have a cycle in some ways. We have social media, as I told you, and the web. It has become an enabler, but then it will leave traces. And so that would become something that would be used for more. And we'll talk about these sort of things later on when we talk about the data science process. I am going to start showing some of my results. You can keep things, discussing things as we are doing. So point number one that has enabled the big data revolution is proliferation of sensors. Think about the watches you have, think about the devices you have, things about that are easy and technology-wise in terms of sensors that are available. For those of you who are in electrical engineering, you can think about sensors that are on the power grid and all very many variations of them. And so we have an environment we live in which things are constantly being censored. That means we've got data. By the way, this is a place where time series data becomes important. I know some of you have responded to my question on the survey. Every time you see sensor, think time series data, think the topic that we'll cover towards the end of the semester, we're having to make use of them. Increased creation of almost all information in digital form. Some of you might remember the times when people have had libraries and archives and things like that. And there has been something that would try to manually digitize them, taking them scanners and things like that. We don't need to do that for much of the things we do because they are just a result of our day-to-day interactions. Think about what happens when you pay your Amazon purchase online and you've got to use your credit card, or think about what would happen when you use your credit card when you pay for coffee. And so everything now, if you really think about it, has been turned into a digital form through datafication. Dynamic hosting storage, you have mentioned this one. There was a time when you need to worry about how much data to store because it was expensive. Now you don't, and that means you would basically store everything. And so this could be both a blessing in the sense that you have everything you need, but it also could be a trouble because now you have to look for things that's of interest in a massive, massive amount of data. But storage, a reduction in its cost is one of the big factors for the revolution we see. Network bandwidth, I think I remember this one being mentioned. We have more of it, and so we can move data to where it is needed. Dramatic cost reduction and scalability improvements in computation. This is both in terms of what computers can do, multi-core and many-core things. For example, my laptop has got many cores, many of you have multi-cores, many of you have things like that. So there is a lot of computing power we have got, even on smaller devices. We have algorithmic breakthroughs, and I want everyone to actually pay attention to this one too, because sometimes the kind of improvement you would get would become even more pronounced because of the power of the algorithms, because of the power of the computing you have. This is my bread and butter for my research, for example. And you will be surprised if you pay closer attention to what you could do if you were able to come up with an algorithm that would reduce your runtime from quadratic to linear, if you're really lucky, or something some in between. And so there is the same computing power, but because of the data mining, because of the machine learning, because of the fundamental computer science algorithm that you have come up with that would be smart and reduce complexity, you could do a lot more. That's what scalability would mean. Even more powerful models producing even more increasing volumes of data. I don't think there was any point in any one of these that I have said that didn't come up in the discussion that I saw on the chat session. So you've done a great job. I think you have participated, although you didn't speak in person. I think many of the points came around. This is a place where I want to break up into sessions. We will start on Friday talking about landscape of perspectives is what I would call it. I want to just have this slide up now, just so you see. For one, I'm going to have two more examples, and both of them will be based on in my view, one of the best articles I have seen trying to articulate what data science is and have some good discussions around applications and things like that. That's what I will spend time on Friday. And I'll post the articles before then so that you get to read them, and we'll have some good discussion around them. But this is a Venn diagram. Everybody's got a Venn diagram, and the data science one has got a Venn diagram. You've seen, I am pretty sure, one way or another, some version of this thing. It's not something that explains everything, and you may not necessarily agree with it in every sense of the word, but I think it is a good way to place where data science is in terms of where it lies in intersections. There is some colorful language here. The person who did this is called Drew Conway, and he wrote an article in 2010 around this and tried to come up with a Venn diagram or try to locate data science. I'm not going to dwell too much on it. It is there, and so you can see what it means. But this is a place where I would like to send you out now to breakout rooms so that you can get to introduce each other. But let me see if anybody's got any question before I send out everybody to a breakout room. So our goal will be to say hi to each other, at least in the breakout room, to put faces to the very many disciplines I have seen last time when I showed you. What's the danger zone? All right, that is Drew Conway speaking. These are his own words, since I didn't want to change them. So they're exact words. It's I think one way of saying that you need to be grounded in good math and stat knowledge, rather than having to just be on a hacking skill, and you may have some substantive expertise in the area. And so I think the point he's trying to make is there is a need for a good grounding in those. That's what it means. Take this one lightly. This is a perspective, after all, and I'm going to have my own and a couple that I think are more informative for us, but this has got its own use. It is, I think it's a good way to describe things. And maybe the distinction between data science and machine learning here is, I think, makes a good point. There is a good amount of emphasis placed on substantive expertise and being closer to the data, and the process that happens before you get to use machine learning is one of the points that you can see now when you look at the intersection, what data science is being, having incorporated a portion of the substantive expertise part, whereas machine learning, the way it is traditionally understood at least, will live in the realm of having computer science and math and stat knowledge put together, and less. This is not an entire picture. This is, a quick view, at least, of having to depict something. So you don't necessarily have to completely agree with it. But that's my take on it. All right. Anybody has got any question?
I have one question.
Sure.
So yesterday we saw one-liner definition of data science, and
yes,
which was something like extraction of general knowledge or something.
Generalizable knowledge, yes.
Yeah. So is this like extraction of general information or specific or critical information? So I have question related to the word general. Is it a general or specific or critical information?
Yes. So that, in fact, that line of definition will be the subject on the first paper we'll discuss on Friday. And so it is a good point that you have asked me now. But what I mean there is to be able to generalize beyond the data that you've seen. So you predict a model. That's when people who have taken machine learning classes would tell you. So can you say something around a data that you have not seen before? Have you been able to generalize? It is in that sense, I mean generalizable knowledge, not something to deduce from what you have seen, and that's all. It is descriptive, but are you able to predict in a fashion that could generalize? That's what I mean. But that point will be clearer when we discuss one of the papers, where that line actually comes from on Friday. All right, let me send you out to breakout rooms now. I'm going to stop sharing this. I think we have enough time. Well, we have 5 minutes. Will it make sense? Helen, do you think it will make sense to go to breakout rooms now?
I mean, it won't hurt anything, I don't think.
Okay. Let me do that. And if anybody has got any questions, you can ask me in the meantime. All right, we are back. I think people are coming back. I hope you have had some discussions with, or at least introduce each other. So I'm going to wait until everybody comes back and then say we are done for today, dismiss the class, and I'll see you on Wednesday. But let me wait until everybody gets back, at least the ones that are able to get back in time. All right, I think I got to be in one of the rooms, and I hope you have had a chance to introduce each other. We will have more of this, and we'll probably have fewer breakout rooms, so I can get to jump to one or another of you. But we'll at least we know if you have not seen this being done before, we know how to get into breakout rooms and get back to breakout rooms. So it's 10 now. I would like to stop here, and we will get back on Friday. The 2 articles that we'll be discussing there will be posted on Blackboard, and the assignment will come on Friday. We want to wait until we have that discussion. So thanks for the time today, and take care, and I will see you on Friday.